This is the third mini lecture for section 13.3 of the textbook. Now we're going to talk about percentile, which is something that's very important for you to understand because it comes up a lot when you teach. And it's something that I think not very many people really understand correctly. So for any frequency distribution, the value x is said to be at the rth percentile if r% of the population is at or below x. And incidentally, the textbook has a typo in its definition of percentile. So a value is at the rth percentile if r% of the population is at or below x. So for example, if you have a student that takes the standardized test and the results say that they're in the 80th percentile, okay, that doesn't mean that they made an 80% on the exam. It means that 80% of the population scored at or below that student. So the percentile does not really say anything about their actual score. It says where they're at in the population. For example, let's talk about the data set from slide 1 of the first section again. And let's just pick a score at random. Let's say 76. So when I look at the data, I have to look at it in order, and the dot plot could help me do this. Okay, 76 is right here. There are two 76s. I see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 scores that are at or below 76. The total number of scores is 24. So I can say 10 scores are at or below 76. Okay, sorry. So 10 scores are at or below 76. And 10 out of 24. Let me work that out. Okay, so it's about 0.42. Okay, so we'll say, and 10 out of 24 is 0.42. So 76 is at the 42nd percentile. So the student's grade may be a 76%. Their percentile is 42 because 42% of the class scored at or below their score. If x is an observation in a data set with mean x bar and standard deviation s, then the z-score of x is x minus the mean x bar divided by s, the standard deviation. The score z transforms a data set into a standardized data set with a mean 0 and a standard deviation of 1. The data set has normal distribution, then table 13.4 on page 717 can be used to determine the percentile of the observation. So for example, let's take our normal distribution with mean 540, standard deviation 60. I want to find the percentile of the score 593. So we have that the z-score is going to be 593 minus 540 divided by 60. And we get about 0.8833. Now I'm going to use that table, page 717 of 718. I don't have space to put it on the camera. So let's see, we have about 0.883. So I'm going to go down the first column until I get to 0.8. And then I read across to 0.083. At 0.88 is what we have on average. And so I get 0.8106. So the table gives us 0.8106. So 593 is at the 81st percentile. So 81% of the population scored at or below 593. Okay, for the same population, let's compute the percent the population between 470 and 610. So I need z-scores for each of these values. We have 610 minus 540 divided by 60. And I get about 1.17. And when I look that up in the table, 1.17, I get 0.8790. Okay, then we have the score 470. And for that, I get about negative 1.17. And I looked that up on page 717. .1210. So when I take the difference of those, that's going to be the fraction of the population that's between those two values. And we get 0.7580. And so the answer is that 75.8% lies between 470 and 610.